In this experiment, we sent balls of different masses down an elevated ramp with and without applied physical force in order to observe principles of Newton's second law of motion, which states the relationship between the net force, acceleration, and mass when the forces are unbalanced. As previously stated, the physics concept used in this experiment was the principle of Newton's second law of motion, which gives the relationship between the net force, acceleration, and mass of an object. This principle emphasizes that the net force acting on the object and the mass of the object will determine the acceleration of the object. For our predictions, since net force is inversely proportional to the mass, we believe that when the mass of the object increases, the net force decreases, or vice versa. The acceleration is also inversely proportional to the mass of the object and will decrease or increase as the mass of the object increases or decreases, respectively. For our results, an approximated acceleration was found by finding the slope of each velocity versus time graph. For trial 1, the acceleration was 857.14 meters per second squared, and for trial 2, it was 315.07 meters per second squared. The ball appeared to travel at a slower velocity when force was applied compared to when no force was applied to the ball. For trial 3, the acceleration was 301.28 meters per second squared, applied to each ball, or a few other factors such as air resistance, which is not being accounted for. From the acceleration calculated from each trial, the F net can be found. For trial 1, the F net was 1.97 newtons, and for trial 2, it was 0.72 newtons. For trial 3 and 4, it was 19.13 newtons and 71.44 newtons, respectively. In the end, the first and second trials were inconsistent with the principle of Newton's second law in that the acceleration and net force decreased with added force instead of increased. Even more, the third and fourth trials should have confirmed that with increasing mass, and for trial 4 it was 1,125 meters per second squared. In this case, the ball moved at a higher acceleration when force was applied. In general, the ball with more mass moved at a slower rate with no force compared to the smaller ball with no force. However, when the force was applied, the ball with more mass experienced greater acceleration. This could be due to a constant amount of force not being acceleration and not force decreases. However, the heavier ball experienced a higher acceleration and a greater net force than the lighter ball, when it should have experienced a lower acceleration and force because the factors are inversely proportional. And lastly, there should have been an acceleration of 9.8 meters per second squared for both the ping pong ball and racquetball in trials 1 and 3, as they both experienced the gravitational force in the same magnitude. The inconsistency may have occurred due to an error with the motion sensor or a misinterpretation of the velocity versus time graph.